Hello and welcome to Algebra 1, Lesson 39. In this video, we're going to learn about factoring trinomials with a leading coefficient of 1. So before we kind of get started, I want you to recall that a trinomial is a polynomial with 3 terms. So in this lesson, we will focus on how to factor a trinomial of the form we have ax squared plus bx plus c. So again, you have 1, 2, 3 terms. Now, this is going to be the scenario that we're going to deal with today where a is always going to equal 1. So observe that a is the coefficient on the x squared term. b is the coefficient on the x term, right, the x to the first power term, and c is just a constant. So that's something I want you to memorize. I want you to write it down on a sheet of paper. I want you to look it over because we're going to refer to that throughout this lesson, and I don't want you to be lost. I'm going to talk about b and I'm going to talk about c. And so again, b is the coefficient for the x to the first power term, and c is just the constant at the end of the trinomial. So we've already learned the basics of factoring, and we're going to kind of take it one step further. So far, we kind of know, if I see something like 3x cubed minus 7x, that I can pull out an x that's common to both. So I can pull it out and write it outside of parentheses, and I would have 3x squared minus 7. All right, we know how to do that at this point. We also know how to do that if we have a common binomial factor. We learn that with factoring by grouping. But this is going to be something that's a little bit different. We're going to take a trinomial and we're going to factor it into the product of 2 binomials, right? Remember, a binomial is a polynomial with 2 terms. So in other words, we're going to be reversing the FOIL process that we learned. So for example, if I have something like x plus 3 times x plus 5, using FOIL, we know that we can do the first terms, x times x is x squared. We can do the outer terms, x times 5 is plus 5x. We could do the inside terms, 3 times x is plus 3x. And then we could do the last terms, 3 times 5 is plus 15. Now, when we combine like terms here in the middle, we would end up with x squared plus 8x plus 15. Now, the question is, if I started out with this x squared plus 8x plus 15, and I asked you to go to this, and you didn't have all this information, how would you go about doing it? Well, the key here is to take this part right here. So let's take the x squared plus 5x plus 3x plus 15, and let's write it in a different way to make something obvious. We're going to factor out an x from these 2 middle terms. So x squared plus, I'm going to stick the x outside of a set of parentheses. It's common to both here. So 5 plus 3, and then plus 15. So the reason I'm doing that is to show you that these 2 integers here that we have inside the parentheses here, the 3 and the 5, these 2 guys are going to sum to give you your middle term in the trinomial. So these sum to give you 8. That's what we have here. So this, remember, this is the b. So we have ax squared plus bx plus c. So b in this case is going to be 8. So again, notice that those 2 integers sum to give you 8. Now I want you to also notice that those same 2 integers multiply to give you 15. Right? C is 15 in this case. So 2 integers whose sum is b and whose product is c. That's what you're looking to find here. So let me erase this real quick. And let's say I started out with x squared plus 8x plus 15, and I said, go ahead and factor this into the product of 2 binomials. Well, start with what you know. You know that you'd have 2 sets of parentheses like this, and it's very, very easy to think about what goes here and here. Remember, the first thing you do is you multiply the first terms together, the f in FOIL. So this times this would give you this. So x times x gives you x squared. And that's always going to be the case when your coefficient for the square term is a 1, right? The first 2 positions are going to be that variable that you're working with raised to the first power. So in other words, if this was p squared plus 8p plus 15, well then the first 2 positions in this case would be p and p. All right, it's the same thing, just changing the variable up. You do the same thing now. Or if I had something like z squared plus 8z plus 15, then this would be z, and this would be z, right? Very, very straightforward. Okay, so once we've figured that part out, that part's a given. So the question is, how do I find out what goes here and here? Well, again, I want two integers. So let me write this out. Two integers where the sum is going to be b and the product is going to be c. So we already know at this point that those two integers are 5 and 3, right? They sum to b. Remember, this is b. And the product is c. Remember, this is c. So 5 times 3 is 15. Again, 5 plus 3 is 8. So those are the two numbers we're looking for. Once we find them, we can just write them in any order. I could put plus 5 and plus 3, or I could switch that up and put plus 3 and plus 5. And you have successfully factored this, right? We know through FOIL, x times x is x squared. X times 5 is plus 5x. 3 times x is plus 3x. Combine like terms there, you get plus 8x. And then we have plus 3 times plus 5. That would be positive 15. And so you get this trinomial x squared plus 8x plus 15 back. So let's just quickly run down the official procedure. So for factoring a trinomial, again, with a leading coefficient of 1, so that a is equal to 1, you're going to look for any common factors first. So just like we saw with factoring by grouping, if you had something like, let's say, 2x squared plus 6x plus 8, I have a common factor of 2, and I could start out by just pulling that outside the parentheses. So 2 times the quantity x squared plus 3x plus 4. I would start out by doing that, and then I would factor what's inside the parentheses into the product of two binomials. So once I've done this, once I've looked for any common factors, and if they exist, pulled them out, I want to, again, find two integers whose sum is b. Remember, that's the coefficient for the x to the first power term, and whose product is c. Remember, that's your constant at the end. If no two integers exist, we have a prime polynomial. So at this point, we're not going to be able to factor that. All right, let's take a look at the first one. So we have p squared plus 18p plus 80. So again, when you first start out, just go ahead and put two sets of parentheses. I notice that there's nothing common to everything, so there's nothing to pull out to start. And so I know that here and here is a given, right? If this is a 1 right there, then it's just going to be p times p. Very, very easy to get the first ones. Then after that, I'm, again, looking for these two positions right here. So give me two integers whose sum is this and whose product is this. So what you need to do is start thinking about the factors of 80. Well, you could make a factor tree if you wanted to, and sometimes that's necessary. Or you kind of just, on your scratch paper, go, okay, well, I got 1 and 80. That's obviously too far apart to sum to 18. I've got 2 and 40. Again, that's too far apart. 80 is not divisible by 3. I've got 4 and 20. Again, too far apart. I've got 5 and 16. That's not going to work for a sum. Then I've got not divisible by 6, not divisible by 7, but is divisible by 8. 8 and 10. So I've found two numbers whose product is 80. 8 times 10 is 80, and whose sum is 18. 8 plus 10 is 18. Once you've found that, you can go ahead and stop. So I have my combination here. And again, I could write this in any order. I could put plus 8 here, plus 10 here, or I could reverse it and I could go, plus 10, plus 8. Doesn't matter. Now, I like to check things. Those of you who watch my videos know that. So let's spend a little bit of time here and just check it. So if I have p times p, that's p squared. Then p times 8, that's plus 8p. Then 10 times p, that's plus 10p. And then 10 times 8, that's plus 80. And you can see that these two middle terms, the sum is going to be this right here, 18p. That's what you're looking for. This number plus this number gives you this number. This number times this number gives you this number. So again, two integers whose sum is b, whose product is c. All right, let's take a look at another one. So we have p squared minus 11p plus 28. So again, I don't have anything to factor out of here that's a common factor to start. So I'm just going to go ahead and write my parentheses. And I know what goes in the first position of each. I have p squared, so that means I have a p here and a p here. P times p is p squared. Now, for this part right here, I need two integers whose sum is now negative 11 and whose product is positive 28. So because we have a negative involved, it's a little bit more complicated. Because now, not only do we have to think about the factors of 28, we also have to play around with the signs to get the addition and the multiplication to work out. So let's just think about the factors of 28. So we have 1 and 28. Those are too far apart to ever produce negative 11, no matter what the signs are. We'd have 2 and 14. If I did 14 minus 2, that would give me 12, so that's not going to work. And if I did 2 plus 8 is 10, so it's not divisible by 3. It is divisible by 4. I can do 4 and 7. Looks like that might work. If I had a negative 4 and a negative 7, negative 4 plus negative 7 is negative 11, right? Sign is the same. Keep the sign the same. And you just add absolute values. So I would have negative 11 from that. Negative times negative is positive. Negative 4 times negative 7 is positive 28. So that is what we're looking for. We're looking for a negative 4 and a negative 7. Again, once you figure out what it is, you just stop. This is just you're listing a list of factors just to figure this out. It's not like your teacher's going to grade you on, coming up with all the factors of 28. So let's go ahead and erase this, and we can check our results. So p times p is p squared. The outer p times negative 7 is negative 7p. The inner negative 4 times p is minus 4p. And then lastly, we have negative 4 times negative 7. That's plus 28. And again, if I combine like terms here, I would have p squared minus 11p plus 28. Exactly what I started with right there. So although it's a little bit more work, a little bit more complex if you have a negative sign involved, it's still pretty easy overall. All right, let's take a look at 3r squared minus 24r minus 27. So one thing you'll notice here is that everything is divisible by 3. Because you might look at this problem and say, well, if I'm looking at ax squared plus bx plus c, well, the coefficient on the squared term, here it's r, doesn't matter if it's r or z or q, whatever it is, the coefficient on the variable that's squared is not 1 here. So if you're in a section where the coefficient's supposed to be 1, that should clue you in that, hey, I need to do some additional work before I can start. And you can see that everything's divisible by 3, so we're going to pull that out. So I'm going to put a 3 out in front. Inside the parentheses, I'm going to have 3r squared divided by 3, that's r squared. Negative 24r divided by 3, that's minus 8r. Negative 27 divided by 3 is negative 9. I'm just going to think about what's inside the parentheses here. So when I set up my kind of two binomials, I'm going to go 3 times, we'll have a set of parentheses, and then another set of parentheses. So nothing has changed. R squared here, I'm going to put r and then r. And now I need two integers whose sum is now negative 8 and whose product is negative 9. Okay, two integers that fit that profile. So let's think about factors of just 9. Forget about the fact that it's negative. Just factors of 9. You've got 1 and 9, and you've got 3 and 3. Well, it can't be 3 and 3 because there's no combination that's going to get you a sum of negative 8. Right? It doesn't matter how you play with the signs. So that's out. So I need to play with 1 and 9. Now, I know that the middle term is negative, and the last term is negative. I can only get that if I have different signs, right? Because we know that a positive times a negative will yield us a negative. So that's how we got that through multiplication. So 1 is positive, 1 is negative. Now we think about the fact that we have 1 and 9. Which one would I make negative? Which one would I make positive? Well, obviously 9 would become negative, right? I put negative 9 and positive 1, and that would get us exactly what we need, right? Negative 9 plus 1 would give us negative 8. Negative 9 times 1 would give us negative 9. So we're good to go there. So my integers would be negative 9, so I'll put minus 9, and positive 1, so I'll put plus 1. And again, I like to check things. So let's erase all this. And let's do r times r, that's r squared. And then r times 1, that's plus r. Negative 9 times r, that's minus 9r. And then negative 9 times 1, that's minus 9. If I combine like terms in the middle, I will have 3 times r squared minus 8r minus 9. And then if I continue, I just multiply 3 times r squared, that's 3r squared. 3 times negative 8r, that's negative 24r. And then 3 times negative 9 is minus 27. And again, that's exactly what we started with right there. All right, let's take a look at another one. We have 2x squared plus 18x minus 20. Again, the first thing you should look at is, okay, all these numbers are even. And the coefficient for the squared term is not a 1. So again, that's a dead giveaway if you're in this section where the leading coefficient is supposed to be 1, that you got to do something first, right? So I know that everything's divisible by 2. I can pull that out. And in my parentheses, I'll have x squared plus 9x minus 10. Now I'm going to factor what's inside the parentheses here. So let's go ahead and set this up as 2 times. We'll put our parentheses for the 2 binomials. And I know that in this position and this position, I have x squared, so it's going to be x times x. Right? X times x is x squared. Now, how do I get these 2 middle terms? Again, 2 integers whose sum is 9, whose product is negative 10. And again, we have a negative involved, so it's a little bit more complex. Just think about the factors of positive 10. Forget about the negative for right now. The factors of 10, you have 1 times 10. You have 2 times 5. Not divisible by 3, 4, 6, 7, 8, or 9. So we can stop there. So obviously 2 and 5 are not going to work. Right? There's no combination with the signs that would get you to a sum of 9. What about 1 and 10? Well, if I had a positive 10 and I had a negative 1, that would work. Positive 10 plus negative 1 gives me a positive 9. Positive 10 times negative 1 gives me a negative 10. So I've found my 2 integers. So plus 10 and then minus 1. Very, very easy. And again, I like to check things. So let's go ahead and do 2 times x is x squared. Outer x times negative 1 is minus x. Inner 10 times x is plus 10x. And then 10 times negative 1 is minus 10. If I combine like terms here, I'd have plus 9x. Now let me scooch this down a little bit. And if I multiply here, I'd have 2 times x squared, that's 2x squared. 2 times plus 9x is plus 18x. And then 2 times negative 10 is minus 20. So 2x squared plus 18x minus 20. And that's exactly what we started with. All right, for the next one, I have 5x squared plus 65x plus 180. And again, if I am in a section where the leading coefficient is supposed to be 1, and it's not, it's a dead giveaway that I can pull something else out. Everything here is divisible by 5. So if I pulled a 5 out, I'd have x squared plus 13x plus 36. All right, so now I'm going to factor what's inside the parentheses here. So let's go ahead and write this as equals 5 times. We'll put the parentheses for the 2 binomials. And I always know that, okay, if it's x squared here, this will be x and this will be x. All I need to figure out is the 2 integers that go in those positions. So give me 2 integers whose sum is 13 and whose product is 36. So let's think about that. For 36, we have 1 times 36. And obviously that's not going to work. For the next one, we could do 2 times 18. That's not going to work. We could do 3 times 12. And that's not going to work. We could do 4 times 9. And that will work. 4 plus 9 is 13. 4 times 9 is 36. So plus 4 and plus 9. And there you go. You have 5 times the quantity x plus 4 times the quantity x plus 9. And again, if you want to check this, which I like to check everything, x times x is x squared. X times 9 is plus 9x. 4 times x is plus 4x. 9x plus 4x would be plus 13x. And then 4 times 9 is plus 36. And then multiply that by 5, and you will get this back. 5 times x squared is 5x squared. 5 times 13x is plus 65x. 5 times 36 is plus 180. It's exactly what we started with right there. All right, let's take a look at m squared plus 9m minus 9. So this is one where we're going to have a problem. So again, you go ahead and start out. Is there anything common to everything? No, there's not. So let me go ahead and put my parentheses there. M squared is the first term, so I know I'll have m here and m here. Now for this spot and this spot, so I need two integers whose sum is 9 and whose product is negative 9. So let's think about the factors of just 9. You have what? You have 1 and 9, and you have 3 and 3. That's it. So I can't use 3 and 3. That's not ever going to work. 1 and 9, if I had negative 1 plus positive 9, that would give me positive 8, and it would multiply to be negative 9, but I don't want positive 8. I want positive 9. If I used positive 1 and negative 9, well, that's going to give me negative 8. And again, I want positive 9. So there's not really anything else I can do. I have to use two different signs because the product here is a negative. And a negative times a positive yields a negative. Right? I can't have two positives or two negatives involved. So I have to have one of these two work out. They don't. And so this polynomial is prime. All right, let's finish up with one that's a little bit tricky. A lot of students see this and they get really, really confused. They're like, well, why is this in this section? You have two variables involved, but what you're going to do is you're going to end up treating one of the variables as just a number, right? So let me kind of explain this to you. You have x squared minus 4xy minus 21y squared. The first variable that you see, the x squared, treat that like you normally would, okay? So when you set this up, just go x here and x here. Nothing else has changed. When you go to find these two positions here, now what I'm looking for is I'm looking for a sum of not just negative 4, I'm looking for negative 4y. I'm looking for a sum of negative 4y. Again, the original variable, the x squared, don't include that. But the other variable that's involved, you will include that. So in this case, that's a y, so you do negative 4y. Then I want a product of this whole thing here, negative 21y squared. So just start out by thinking about the number. For 21, I have 1 and 21. It's not divisible by 2. It is divisible by 3. I have 3 and I have 7. Now, I already know that if I work the signs correctly, I can get negative 4 out of 3 and 7. Right? I can do that. So let's think about that for a second. If I had a negative 7 and a positive 3, negative 7 plus 3 would give me negative 4. Negative 7 times 3 would give me negative 21. So I could put negative 7 and plus 3. Now, what about the y part? Well, you just throw it in there. Just put a y here and a y here. And think about it now. Negative 7y times 3y would be negative 21y squared. Negative 7y plus 3y would give you your negative 4y. So everything works out there. When you see something like this with two variables involved, it's no more difficult. You just have to kind of think about that second variable that you see as if it was a constant, right? As if it was part of the number that you're working with. So in other words, again, when you look for your sum, you take negative 4 and then you just include the y. So I'm looking for the sum of negative 4y. And then when you think about your product, include the whole thing. I'm looking for a product of negative 21y squared. So again, I like to check things. X times x is x squared. Outer x times 3y is plus 3xy. Inner negative 7y times x is minus 7xy. These would combine together to be negative 4xy. And then negative 7y times positive 3y would be negative 21y squared. So again, if I combine like terms here, I get x squared minus 4xy minus 21y squared, which is exactly what I started with right there.